Hi everybody, this is Shiva Veeram signing in. Viewers అందరికి కూడాను శ్రీ క్రోధినామ నూతన సంవత్సర శుభాకాంక్షలు. Actually, this is my 100th video that I am doing. I thank one and all who supported me in making this many number of videos, who encouraged me. This video presents the introduction to parallel operation of alternators and also the functioning of Synchroscope. So we are going to see what is the necessity of parallel operation of alternators and what are the conditions to be fulfilled to operate the alternators in parallel, and how Synchroscope is going to help us in synchronizing the alternators, or to run the alternators in parallel, how Synchroscope is going to help us. So all these things we are going to study in this particular presentation. Once again, I thank all the viewers who supported me in making such videos. Let me go through the presentation. So here we are going to learn the necessity of operating the alternators in parallel. First of all, let us see what is the need. So if one unit is considered, one unit of alternator is considered, the power interruption will be there if at all any problem is going to happen with that. So if you have number of alternators running in parallel, if one mission is going to be interrupted, the others can carry the load temporarily until the faulty one is going to be repaired. So that is the major advantage or major necessity that we are required to run the alternators in parallel. And what are the conditions for operating the alternators in parallel? So directly we cannot connect two alternators in parallel to the bus bars. It needs certain conditions to be fulfilled in order to connect the alternators in parallel to the bus bars. Like we shall discuss all the things in detail in the coming slides. First of all, let me brief you. Like the voltages of the incoming machine should be same as that of the bus bars, and the frequency is one of the important parameters which is to be same as that of the bus bars. If the bus bars are going to have the frequency of 50 Hz, the incoming mission also should have the same frequency. So these conditions are must for parallel operation of alternators. And when you consider the three phase, the phase sequence also should be the same. So generally the phase sequence depends upon the direction of rotation. It can be either RYB or RBY. So whatever phase sequence is there with the bus bars, the incoming mission which is to be connected in parallel with the bus bars also should have the same phase sequence. So these are the conditions which are to be satisfied. So we shall see all these things in detail. And the principal functions and working of Synchroscope. Synchroscope is one of the equipment by which we are going to synchronize the alternators, or you can connect an incoming mission parallel to the bus bars, or another mission which is already synchronized. So already we have seen how the continuity of service is going to be if we have the alternators running in parallel. So even in the event of breakdown of the prime mover or something happens, the entire station is going to be shut down. I mean, if the parallel operation is not considered. So if several small units are run in parallel, even one unit fails, the power is supplied by the remaining units temporarily. So that is the major advantage that we are going to have it, and even that is the main necessity that we should run the alternators in parallel. And the efficiency also can be improved. So when the load is increased, generally the demand may not be constant, and in future some more demand may be required, because the power requirement will be very much high in the coming days. So when the future expansion is required, it will be very comfortable for us to run the machines in parallel. It will be very convenient for us. The maintenance also will be easy for us. And already I told you that the extension of power plant. So to have the future demand requirement, it is almost essential to run the alternators in parallel, so that we can add extra units to the bus bars, so that they can share the extra amount of load. So if single unit is used, the extension of power plant will be difficult, because only one alternator has to bear the entire load, so which is highly difficult. So the process of connecting two or more alternators in parallel is known as parallel operation of alternators, or this can also be considered as synchronization. Now let us see the conditions of synchronization of alternators one by one, or you can say parallel operation. The first one is equal terminal voltages. So the voltages should be the same for the alternator which is to be connected in parallel. So generally the alternator which is to be connected in parallel is termed as incoming mission, and which is already in parallel with the bus bars, which already connected to the bus bars, that machine is considered as existing mission. So these two, the terminology is a little bit essential for us to understand things. So generally the voltages are going to be maintained constant by adjusting the magnetic flux or magnetic field strength of that particular incoming mission. So here already this particular mission A is connected to the bus bars, and B is to be connected to the bus bars, or which is to be synchronized, or which is to be connected in parallel. All these terms are same. So here B is considered as incoming mission. So in order to have the same voltages, we have to adjust the field of this generator, and we have to see that the voltage of this mission should be same as that of A or bus bars. So once these voltages are same, then only we can close the switch so that this can be connected to the machine. Of course, subjected to other conditions are satisfied. Now let us see the second one. The condition 2 is equal frequencies, and the frequencies, in order to maintain the frequencies as constant, we have to see the prime mover should be having the same speed as that of the existing machine, and by adjusting that speed of the prime mover, we can adjust the frequency of the incoming machine. So this is the second condition which is to be fulfilled. And the third one is phase sequence. Already I told you the phase sequence can be of two types. One is RYB, another one is RBY. So whatever phase sequence is there with the bus bars, the same frequency is to be maintained by the incoming mission also. And this can be obtained by adjusting the connections of the alternator to be connected in parallel. So once these three conditions are satisfied, then only we can synchronize, or we can connect the incoming mission B to the bus bars. So already I told you, synchronization is the process of connecting alternators in parallel. So the method of connecting the alternators in parallel is known as synchronization. Now let us see how the Synchroscope. Actually there are so many other methods are also there to connect the parallels, to connect the alternators in parallel, like dark lamp method, bright lamp method. Like the different methods are there, bright and dark lamp methods, and Synchroscope is also one of the equipment which is going to help us to connect the alternators in parallel, and this one is frequently used even in industrial sectors also. So I would like to introduce this Synchroscope here, and how it is going to function, and how this is going to help us in connecting the alternators in parallel. And another advantage of Synchroscope is it is also going to tell us whether the incoming mission is going to run a little bit faster or slower. So we see all the things how. Basically it consists of two important parts, that is rotor and stator, so which are wound for a two-phase system. Both are wound for two-phase system, and generally the rotor is supplied from a two-phase supply, and this two-phase supply will be from alternator which is to be connected in parallel. Hope it is clear to you. So here the rotor of this Synchroscope is going to be supplied from the alternator which is to be, from the two phases of the alternator which is to be connected in parallel. So if the two phases are synchronized, then automatically the third phase is also going to be synchronized. So this is how the synchroscope is going to be. Let me explain you the constructional parts. Here you can see the middle winding which is going to have at the center part. So this is known as rotor part, and above this rotor we are going to have one more winding which is bound for two phase, which is known as stator. So here it is clearly indicated that the stator is going to be connected to the bus bars, and the rotor terminals are going to be connected to the incoming machine, which is going to be connected in parallel. And to this rotor we are going to have a pointer which is representing on a dial, which is going to be represented on a dial. Onto the right hand side it is represented as fast, and onto the left hand side it is represented as mentioned as slow. So depending upon the frequency of the incoming mission, the pointer is going to show whether it moves faster than the required one or slower than the required one, and correspondingly we have to make the adjustments, and we should see that the pointer should show this 0 value. So the supply to the stator of Synchroscope, stator is given by the existing alternator or the bus bars, whatever it may be, and the supply to the rotor of the Synchroscope is given by the incoming alternator. Just now we have discussed in the previous slide. Now let me explain you the functions of Synchroscope. It indicates the difference in phase and frequencies of the alternators which are to be connected in parallel. So this is one of the important functions of Synchroscope. So if at all any difference in phase is there or any difference in the frequencies is there, this is going to be shown or represented by the Synchroscope. This is how we are going to have the dials for a Synchroscope. It also indicates whether the incoming mission is running slow or fast. Just now I have told you, depending upon the pointer position, whether it is going to represent slow or fast, we can understand whether the incoming mission is running at higher speed or lower speed than the required one. So the working of Synchroscope depends upon the difference in frequencies of alternators which are to be connected in parallel. So if no difference is there in the frequency, the rotor on stator, the pointer remains standstill, means it is going to show the 0 value. So in the middle position it is going to stay. If at all any difference in the frequencies is there, the rotor is going to rotate either clockwise or anti-clockwise, representing there is a difference in the frequency or speed. In turn, frequency difference means it is going to reflect the difference in the speeds of the prime mover. So the difference is greater, the rotor speed will be greater. So if the difference in the frequency is less, the rotor speed will be less. So there will be a proportionality relationship between the difference in the frequencies and the rotor speed. That's all for today's session. I hope that this particular video is very much useful to you. Once again, I thank all my viewers for supporting me in making this many number of videos. మరొకసారి వ్యూయర్స్ అందరికీ కూడాను శ్రీ క్రోధి నామ నూతన సంవత్సర శుభాకాంక్షలు. And finally, your valuable feedback is highly appreciated, and don't forget to subscribe to my channel so that you can have more videos. Thank you very much. This is Shiva Biram signing off.